Hey there everyone, my name is Hitesh and I make coding related videos. In this video, I want to discuss a really interesting system design topic. Now most of the time, when you study about system design, it's usually through the books. I also study from books, they are great resource. Sometimes you study from research paper, they are also very futuristic. But here is something that is coming up directly from the industry that is being used right now. Yes, we're talking about Kafka versus Ingest. Now, this is something absolutely new. When simply you study any book or any research paper or any YouTube video guide, I know that you have studied about Kafka. This is kind of a prominent chapter in the book of any system design, but what you don't see in those chapters is ingest. Why so? Because things like ingest are very new. They are not yet adopted that much, but they are on their way to get adopted so much because they are actually serving a real use case. And Kafka was not there in the books of system design, but when it has proven its importance, then it got its place in the system design books. Exactly same is happening with the ingest. Ingest follows a step module and it is by default high in scalability. The infrastructure is really awesome in that. So it makes it obvious that somebody needs to come up and talk about Kafka versus ingest. And don't you worry, in case you don't know anything about Kafka, this video is a great starting point. I will walk you through with the entire detailed structure of Kafka. Even I'll show you the code part of it. Then I'll take you in the ingest side of it, that how ingest is comparable for it. And then I'll show you some of the ingest code, real world code, that you can compare with the Kafka code and see what are the pros and cons of each of them. Always remember, there is no good tech, there is no bad tech. It's all about pros and cons. Sometimes for some of your use cases, some tech really thrive. In some of the cases, other tech thrive. That's the whole point. Hope you're excited for this. Let me take you onto the screen and let's talk about Kafka versus ingest. Great topic. Let me take you there. So once we are here, I have actually prepared a whole lot of diagrams and whatnot and stuff for you so that you can actually understand. So we have two topics to discuss here, the Kafka and the ingest. First, we'll go through with the Kafka details and then I'll walk you through with the ingest and all the details. And then we have some of the code on the Kafka and ingest. So this is how we'll be walking it through. The step one is to first learn and understand what is Kafka, why it exists. Now Kafka, it's a great product. It was designed mostly within the LinkedIn itself, but it's available everywhere and you can use it. But the bigger question is, why does anybody needs Kafka and what even it does? So Kafka is also known as Apache Kafka is a distributed event streaming platform. Now this is a lot for a definition. So distributed means, yeah, it's just like distributed systems are there, it is same distributed, but where you should be focusing on event streaming platform. Now, this might sound similar to some of the queue system that you have, but the queues are different. Anybody just, if a message goes into the queue or some work goes in the queues, a consumer of the queue picks up that work or task and then removes it from the queue itself and just process that task. Kafka is in itself different from that whole process. So let's go through with this diagram. So at the heart of this diagram, we can see this is a Kafka. By the way, this is a logo and symbol of a Kafka. You can go and visit their website as well. They also do a pretty good job in explaining this. Now, whole of your events are actually being placed inside this Kafka. Kafka has something known as producers and consumers. I will walk you through with that part as well. But what you need to understand at first is Kafka is at the center of it. And here all the messages and producers, all the content is actually there. It could be an event, it could be some data, it could be some hint that you need to process some videos or something like that. So all of that goes into the Kafka. Now, in the queue, you actually pick up that message and that's it, the message is gone. But in Kafka, the message doesn't leave until a certain time. You can configure that for 7 days, 6 days, 1 day, whatever you wish to have. But that message doesn't leave it automatically. And Kafka is known for its scale of streaming. So it can stream this event, whatever the first event has come to you, onto all of these services. Now look at this. Maybe an event has happened onto your website. It could be a sales order. It could be a purchase order. It could be a YouTube video that you have viewed just right now. So it obviously needs to go in the database first. That all right, somebody has watched this video and this query shouldn't happen all the time from the database. So it also needs to go in the Redis, an in-memory database. Maybe you want to process it further. So it also needs to go in the data lake as well. Or maybe you want to do some analytics from it. So it needs to go into analytics engine as well. Maybe you want to see and find the pattern of what kind of videos I do watch. So in that case, it goes into some kind of machine learning model or the AI model. And since this event is being consumed, somebody needs to inform the user, hey, this video is already being watched. So it needs to be, the event needs to go on the web as well. And then maybe you're monitoring some of the behavior of the user. So you can see just one event needs to go so much. If you do it through the traditional way of writing the software, you can see your controller can go really long before it sends the response back. But this doesn't happen in the real world and high scalable systems. In this, we use services like Kafka, in which your job once the event has happened is just to inject that event in the Kafka. That's it. Now it's the duty and the job of these databases, this Redis and data lake, and the softwares are written in such a way that it automatically streams those events in these services. Now let's revisit the definition again. Apache Kafka is a distributed event streaming platform. Now it makes more sense. Let me also walk you through with an example. So first of all, the Kafka actually helps you to send message between the system. You can see the system, it acts like a post office for the data. So it sends event between multiple of the system. It is designed for high throughput, millions of messages per second. This is one thing where Kafka really shines. I don't think there is anybody out there who actually handles the scale of Kafka, but there are only a handful of applications which are on the scale of probably LinkedIn or YouTube. There are only a handful of them. And it's also fault tolerant and scales horizontally, works across many servers. Now here's the interesting thing. When I say that this thing actually works across many servers, this means, yes, you have to run and manage a lot of servers. And installing and making this Kafka fault tolerant and scaling is no joke. Somebody needs to handle these servers and all these stuff. So it's not that easy that it looks like, but here is an example that I would love to give you. So imagine this is a user and this user comes up and says, hey, I would love to watch a YouTube video. He clicks on the video just like you're watching this one, and that's it. What happens after that? The job of this YouTube video is to take certain amount of data. I have just used an example data here, like video ID, who is the user who is watching it, and what kind of watch time he's doing. So he just injects this whole thing or this whole data in the Kafka. Now this Kafka service is attached to multiple of the things. Now what happens within the Kafka is itself, Kafka can create multiple topics. Now each topic, you can subscribe to any topic that I'm interested in this topic. Like if there is this kind of data that's coming up, why would a purchase service would be interested in subscribing this? Purchase service would be interested in subscribing things like you have bought a YouTube premium. So that makes sense. So your video views or something needs to send me the video ID, the user ID, and the watch time. So these kinds of things are going to be interested or injected in some topic, and that topic will be subscribed by an analytics dashboard. You want to see that in history, or maybe somebody needs to behind the scene analyze what kind of things you are watching. It also needs to be consumed by ad service so that they can know your preference, that do you watch more tech videos or mobile unboxing videos, or maybe you're interested in camera, or maybe you're interested in taking a loan, who knows. So those ad service needs to consume this topic. Then there is a recommendation engine as well, who determines that what video you should be watching next. So there's so much of happening, so many of probably microservices or maybe whole new system. But the beauty is that through the Kafka, that whole application may be built in Fast API, maybe in Django, maybe in Express, whatever they're using. They can just go ahead and consume this topic. But here's a big problem with the Kafka. It's not a problem, it's supposed to happen. It's infra management. Infrastructure in the Kafka is a no joke. If anybody walks and tells you that I can manage easily, it doesn't work that way. Kafka management, it requires so many of the servers. The servers needs to be always up and running. It needs to scale horizontally. So many of these services like analytics dashboard, ad service, Redis, database, they will be querying you back to back. So you need a really high throughput for that. And this is the Kafka. Now there is a new player in the market which is challenging not directly to the Kafka, but their way of working is entirely different. Now the new kind of frameworks and infrastructure is coming up, which is entirely based on the steps. If you just go and look at the Inngest platform, they says develop AI product at the light of speed. I don't think so. It has to do so much with the AI itself, but rather they are kind of a new way of writing the backend itself, and I'm becoming a big fan of it. And look at the trusted platform, TripAdvisor to Resend to a whole lot of people. This is where the infrastructure is actually explained much better here. So if you just look at this, everything is a step. Step run this, step run this, step run this. And by the way, I forgot to show you how the Kafka code looks like. So this is how the Kafka code looks like. This is very dumbed down version of it, but I'm just importing a Kafka JS. I haven't installed it. I'm showing you this is how it looks like. So you create a Kafka object and it requires a client ID and who is the broker, like what is the server which is serving this Kafka. Then you simply go ahead and create a producer and consumer. This is the whole heart of how the Kafka works. Producer produces the content, consumer consumes the content, and there can be endless consumer. So this is what producer does. A producer simply goes ahead and connect, and then it is simply sending that, hey, I have a topic for you, which is chai order. So whoever are interested in these chai order can actually subscribe to these chai order, and you will be made available with the information of whatever there is in the chai order. Then you simply go ahead and put some message. You can provide any data in the message. So this is job of the producer, that it is sending a message in this topic. There could be any topic and can be any number of topic. And then the consumer, whoever is the consumer code, they just simply have to say consumer. Of course, you have to create the consumer, which we have just created with the consumer. We need to know the group ID of it. So group ID is just chai group. Every kind of consumer needs to have a group ID. Then we simply go ahead and say, I'll connect my consumer, and then I'll say, I want to subscribe to a topic known as chai order. And that's it. From beginning true, because in the Kafka, the things are always there. So you can just say that, hey, from this point onwards, I'm connecting and I need orders after that, or I need all the orders which are there in the Kafka itself. So that's what the parameters does. And after that, you simply say consumer.run each message, just consume the each message. It sounds simple. It is not that simple, but I hope this code actually gives you an idea. So this is one way of writing the Kafka code itself. Now let's go ahead and see on to ingest. Now, if you see the ingest code itself, it's a whole new paradigm of writing the code. Step is actually at the heart of everything. So step.run, step.ai.infer, and publish. Basically what they're doing is everything needs to run in this step itself. Instead of actually relying onto a central place where everybody comes and picks the consumer, the whole goal here also in the Kafka, if you look at the closely into this, the goal of the Kafka is to do this activity, then this activity, then this activity. And if I just add a step that, hey, step 1 is do this, step 2 do this, and all these step 1, step 2, and step 3 are independent of each other, that's it. We have achieved that exactly what we wanted to achieve through this input itself. Now, if we know that we need to run all these steps and they can run asynchronously, all of them, that's it. The job is done. And that's exactly kind of philosophy that's coming in, a new style of writing the entire system through the ingest platform. And I'll walk you through with the code part as well and how they offer it. But let's first go into the system design of how things actually work. So the way how ingest works is it's an event-driven workflow platform. As you can see, it's an event-driven. A certain event needs to happen, and after that, all the follow-up events can happen. Built for developers to run background jobs. And of course, the database, the Redis, the analytics, you just need to send the information there. And it has automatic background jobs, retries, and the workflow without infra management. Now, this is their biggest selling point, without the infrastructure management, because the choke point of the Kafka is that it's heavy on the infra management itself. But what they do is in the ingest itself, it's all event trigger functions like serverless workflow. It's kind of serverless. It is serverless. So you can just trigger an event and after that, all the follow-up happens automatically. The best part is they automatically have the retry logic, the scheduling, the fan out, the chaining. If you have any time studied a little bit of the system design, these terms are common there. And these are the terms which makes or break the decision of using any software, whether it's Kafka or ingest. So once they have all of this, that means, hey, they are competing neck to neck with the Kafka itself. But where they outshine the Kafka is it's their developer first approach. You write code, ingest run it, and ingest run it when events are fired. So ingest take care of everything. You just focus on writing the code itself. I'll walk you through with the code itself as well. Don't you worry on that. So ingest take care of queuing, retry, scheduling, and even step workflow. That is it. And what I really like about ingest is its developer-friendly event workflow. For example, we have the welcome email, billing retries, cron jobs, webhooks. All of these things are kind of a part of it, and that's why we have these resilient system that we don't remove the message from the Kafka itself. Maybe it didn't gone through with all the work that I wanted to have. So it will just retry. So all these things are already cooked up in the ingest itself. It can also run the background jobs. So a lot of job these days needs to run in the background itself. It used to be done previously as well, but now it's more required. Previously, the jobs like you want to process your videos on a YouTube upload or any LMS platform upload, these things needs to happen in the background. Now with the AI itself, a lot of things actually happen in the background. So once you have sent the message to the AI, it might take some time to actually get back to your message. Or maybe when you are sending a request to generate an image, it obviously takes some time. So these kinds of things needs to happen in the background or into a separate service itself. If you put a separate service, Kafka and all of that, probably you don't need that. You can just use Ingest for that. And then we have these coordinating multi-step process. I'll walk you through with this one because this requires a little bit of code to understand it, what it's like, order place, charge cards, send. I'll walk you through with that because this requires a little bit of the code understanding, and then I'll come back here as well. So this is what the code looks like for the ingest application. And don't worry too much, it's a simple express application. We have the serve coming up from the ingest express, and then we have the ingest. The serve is doing not too much. If I just walk you through, this is how the ingest actually serves. So ingest has its own platform or a web view to actually look what's happening, to entirely see the flow in itself, as they mention in their homepage and the diagrams. So this kind of a flow, if you look at this, yeah, this kind of a flow that happens. If you want to see all of this, that's where this serve actually come. This one is nothing. It just says, hey, I'm a route which says demo. If you hit this route, it sends a signal to the ingest. So this is the name of the event, and this is the data that we are sending to the ingest itself. Now what happens when you send that? As I mentioned here, that the ingest, the whole point is that it's an event-based flow. If you look at the diagram very first, event-driven. What is the event here? In our case, the event is this here, user/register. It could be any name, but it's a common pattern that they mention in their website. Now what happens? Here is the interesting thing. All right. So as soon as the event happens, Ingest actually creates a function which says, this is a function for welcome flow, and you have triggered an event to run this entire welcome flow. And this is the event I'm looking for. As soon as this event happens, a lot of things happens. What? First of all, you simply go into this event and the steps. So this event happened. You simply extract the payload from the event itself. And in this case, it's just the email. I check for the email, whether it's available or not. Very basic. But after that, I have induced this artificial delay so that you can see, oh, some step is happening. But it's up to you. You want to do it or not. That's not anything. Now notice this. The step 2 is, and you don't write step 2 and all of that because all of them happens await async itself. So you can just run the step which says send a welcome email. Now this is a whole in itself as a service itself. It will do all of its magic to send the email. It's independent. If it will fail, it's not like the whole code will fail. It will just fail on its own if it fails. Then we have a step 3. Step 3 is simply to add the user in my CRM or the database. So if I just go ahead and work with that, it added in the CRM. So even if email works or not, doesn't really matter. Even if it is able to add this user into CRM or not, we can look for where the things are actually failing. It automatically just retries, and you can configure the things for retrying this. Even if retry this step fails, it notifies you as well. All of these things are actually made happen up here. So you can see this one actually looks like a lot of code compared to the Kafka, but what you don't understand, this code is not going to run as it is. It requires a whole new service of a broker to be deployed on some of the servers, and somebody needs to manage this server. In this application here, you're just writing it and Ingest does it everything for you. And by the way, in case you are worried on that part, if you look on this, yeah, there's the open source button of the Ingest, and you can just go ahead and look onto this. Hey, what's happening in the Ingest in this part? You can just go ahead and look at this, peek into it. So this is the whole part of it. So I am truly enjoying these event-based architecture. By the way, this is how it looks like. So notice here all these steps. You can actually go and check all the steps which are running, which are completed, which one has failed. You get all the logs and stuff. So my point is that in these kinds of system design talks, I've rarely seen anybody talking about the Kafka and Ingest. And by the way, full credits to the Ingest itself. Actually, the idea came from them itself. I was just hanging around in their blogs, and they were actually talking about this traditional queues versus Kafka. And I realized this is not enough. You can read this article. I'll link it in the description as well. But I think it requires a little bit more talk, so I created my own notes, fresh ones, and thought to discuss with all these things with you. So this is all about a really, really different talk on Kafka versus Ingest. And I hope that you have enjoyed this one. Very fresh take, very raw take, and gives you an idea of something new that's coming up in the whole development infrastructure. That is it for this video. Let's catch up in the next one.